Today we'll go over the LeetCode hard question, trapping rainwater. The question is, given n non-negative integers representing an elevation map, compute how much water it can trap after raining. This is a very popular interview question, so let's get into it. Here we have an example of an elevation map represented by a list. Each integer represents the height of a block. In this example, we see that water is being trapped here, here, and here. And the total area is 1 plus 4 plus 1, which equals to 6. How do we solve this? Pause here if you want to think independently first. My first intuition is to break the problem into smaller parts. You can see that water is being trapped in different sections. I'll label these section 1, 2, and 3. For section 1, water is being trapped in this subset of numbers. For section 2, it's trapped between 2, 1, 0, 1, 3. And for section 3, water is being trapped between 3, 2, 1, and 2. What can we learn from these numbers? We see that water is being trapped between the left and right edge, and the amount is determined by the smaller one of the two. For example, water reaches the height of 1 in section 1, 2 in section 2, and 2 in section 3. Now, how do we determine the left and right edges of each section? Pause here if you want to think for a moment. In fact, we don't have to split the list into multiple sections because the water trapped at each location can be calculated independently. At each location, the amount of water trapped is the minimum of its left edge and right edge minus its height. The left edge is the highest block from its left, and the right edge is the highest block from its right. This means we need to calculate the left max and right max at each location, and we can do that by having moving pointers. We'll place an arrow pointer on the left and a star pointer on the right. And left max and right max are the pointer values. In this example, 0 is smaller than 1, so the minimum of left max and right max is the left max. Can we determine the water trapped at the left pointer? Yes, this is because for the left pointer, left max is accurate. What about the right pointer? The answer is no. This is because for the right pointer, left max is inaccurate because it hasn't seen all the numbers to its left yet. So in this case, we calculate the amount of water trapped at the left pointer and move the left pointer forward. Let's look at the case when the left pointer is pointing at 2 and the right pointer is pointing at 1. In this case, the left max is 2 and the right max is 1. The minimum of the two is the right max. What can we say about these two pointers now? In this scenario, we can only calculate the water trapped at the right pointer because right max is only accurate to the right pointer. Now let's translate this into code. This is the pseudocode in Python. The stopping condition is when the left pointer and right pointer meet in the middle. But before then, at each step, we need to update the left max and right max. And based on which one is bigger, we update either the left pointer or right pointer and move them forward. The time complexity is O(n) because we only need to loop through the list once. And the space complexity is O1. And this is it. Let me know what other questions you want to see, and happy coding.